morning again. How are you, my kids? It's Murad Sultan Azwili again with you. Yesterday we saw how can you reflect shapes and let's say in the line y equal x and y equal negative x and in the y-axis and x-axis using of course algebraic techniques and not geometric techniques. Okay, we stop at this point. Today we'll try to continue rotating or transforming shapes using rotation 90-degree clockwise or anti-clockwise, okay, about the origin, then 180-degree about the origin of course, and 270-degree anti-clockwise about the origin, okay, and so on. Then we move to the enlargement. So please, my kids, don't forget first to join your classroom, okay, and try to interact with the worksheets that I already gave, okay. And it worksheets is 4 out of 4 or 3 out of 3, okay. This depends on the number of the questions, okay. So please don't hesitate to do your assignment sheets and send to me, okay. Thank you for that. Now we start. The lesson is what, my kids? Matrices for rotation, okay. So before, my kids, we saw what exactly? Matrices for reflection. For what? For reflection, okay. Matrices for reflection, okay. Matrices for what? For reflection, okay. Matrices, okay, for reflection, okay. We saw what exactly? We saw in the x-axis, in the x-axis, then in the y-axis, then in the line y equal x, and in the line y equal negative x, okay. So now we will continue how can we use matrices to rotate or to enlarge, okay, shapes. Okay, the matrices derived for rotation are defined for an anti-clockwise rotation about the origin. Anti-clockwise or counter clockwise, okay. So about what? About the origin of coordinates. Origin is 0, 0, okay. In each case, the matrix A, B, C, D represents an anti-clockwise rotation about the origin. Also, we should know that a counterclockwise or an anti-clockwise rotation of 90-degree is the same as a clockwise rotation to 170-degree. So we need not to derive matrices for clockwise rotation. Okay, we try to work with counterclockwise or anti-clockwise rotation. Okay. And in general form, to find any coordinates of the point A, let's say in the rotation about the origin 0, 0 and 90-degree. So just you will use what we saw before. A, B, C. This is a matrix, a square matrix of order 2 or a matrix of order 2 by 2. Multiply by what matrix? Multiply by the column vector of the element of the point should be equal to the color vector of the image. Okay, the vector of the image. So let's continue. In general, matrix for rotation is the matrix of rotation. This is A, my kids. This can be written as A, B, C, and D. Where A equal cosine of theta, B equal cosine of negative theta, and C equal cosine sine of theta, and D equal cosine of theta, whatever be the angle theta. Okay. So, in general, I always try to work with this point, my kids, with the point 1, 0, and what else? And this point is 0, 1. Okay. So, if theta equal 90 degree, the matrix for of transformation or the matrix for rotation 90 degree anti-clockwise above the origin is cosine of 90. Cosine of 90 is 0. Minus sine of 90 degree. Sine of 90 degree is 1. So it will be minus 1. Then sine of 90 degree is 1. And cosine of 90 degree is 0. Okay? So this one is very important, my kids. Okay? So, if theta equal 90 degree, the matrix is 0, 1, negative 1, 0. Okay, let's check, my kids. Let's start with the point 1, 0. 1, 0. This is 1, 0. Okay, I will rotate this shape 90 degree. Okay, it will be what? 90 degree. Okay, anti-clockwise like that, from right to left. This point has the coordinates 1, 0. When it rotates 90 degree, it will be what? It will be this point. It will be 0, 1. So, 1, 0 maps to what? Maps to the point of coordinates 0, 1. Okay? So, 0, 1. I will just write here 0, 1. Then, the next one. So, in order to find AC, I should multiply this matrix by the column vector 1, 0. 1, A multiplied by 1 is A. Okay? And C multiplied by 1 is C. So, equal what, my kids? Should be equal to 0, 1. So, these two matrices are equal. And they have the same order. You can equating their corresponding elements or numbers or value or entries. So it means A equal 0 and C equal 1. Okay? So A equal 0, C equal 1. For the next one, for 0, 1, this point, my kids, 0, 1, I will rotate it 90 degree anti-clockwise. So the point will be what? The coordinates of this point will be minus 1, 0, isn't it? Minus 1, 0. So, this is, my kids, the second column vector. The second column, it will be negative 1, 0. This is, in fact, my matrix, okay, for rotation anti-clockwise about the origin 90 degree. Okay, 0, 1, 0, 1, minus 1, 0. Okay, you can also use this by substituting in this trigonometric function theta equal 90 degree. Okay, then for the next one, we thought 0, 1 maps 0, 1 maps to what? Maps to negative 1, 0. Okay, hence that the matrix for transformation that transform this point to its image. Okay, so it will be A, B, C, D times 0, 1, the coordinates of this point. That maps, in fact, to this point, which has coordinates of negative 1, 0. Negative 1, negative 1, 0. Okay, now my kids, if you would like to work out B and D, because A and C we found the value of A and C. Now we would like to find the B and D. So just multiply
A by 0 is 0. B multiplied by 1 is B. Okay. Then C by 0 is 0. D multiplied by 1 is D. 0 plus D is D. Okay. Equal what? Equal negative 1, 0. So, both matrices are equal. Okay. And they have the same order. You can, let's say now, equate their corresponding entries. Means B equal negative 1. Means B equal what, my kids? Equal negative 1. And D equal 0. So, this one represents what? My matrix of transformation of a point, for example, A of coordinates 1, 0 to its image, it will be 0. And from 0, 1 to negative 1, 0. So now at least we can work out this matrix that transform A into B. Okay? And the rotation, of course, about the origin, 90-degree, counterclockwise or anti-clockwise. So the matrix for an anti-clockwise rotation about the origin through 90-degree is 0, 1, negative 1, 0. Is 0, 1, 0, 1, negative 1, 0. Okay, in general, my kids, if you'd like to transform or to find the image of any point, okay, through, let's say, and the rotation, okay, about the origin 0, 0 and through 90-degree anti-clockwise, okay. So we should use this matrix for transformation and multiply by the coordinates given of this point. You will find the image. Okay. So here we have an exercise. One volunteer carried the exercise. The triangle A, B, C has coordinate of 1, 1, 2, B, 1, 4, B, 1, 4, B, 1, 4, then, and C, negative 1, negative 3. Determine the coordinates of the image of the triangle A, B, C in the rotation about the origin through 90-degree. Through what? Through 90-degree. Through 90-degree. Okay? So, first of all, before guessing what is the exactly the coordinates of their image, we should work out or write your matrix of transformation. The matrix that transforms this point to its image. So the matrix is what? For rotation, of course. We told that 0, 1, y 0, 1, look. This is the x-axis. This is y. This is 0. This is 1, 0. Okay. This is 0, 1. Okay. And this is what? Negative 1, 0. We told what, my kids? We told this point has transformed here about the center 90-degree. Okay. And this is the center. So the coordinates of 1, 0 will be 0, 1. So this is 0, 1. Then this is the next point. I will rotate this one here, my kids. Okay, 90-degree anti-clockwise about the origin. It will has the image will be negative 1, 0. So this one, my kids, is your matrix for rotation 90-degree anti-clockwise about the center of the rotation, which is the origin. Okay, so we have 1, 2, negative 1, 3. 1, 2, negative 1, 3. 1, 2. Then negative 1, 3. Negative 1, negative 3. Okay, what else? We have, okay, and 1, 4. 1, 2, negative 1, negative 3. 1, 4. Okay. And we have 1, 4. So, this one, my kids, is what? This is, okay, this is A. Okay, this is C. The coordinate C. This is the point
B of coordinates 1, 4. Okay. Now, the matrix for rotation about the origin through 90 degree, my kids, through 90 degree is what? We told you that. So here we have an exercise. Okay, A of coordinates 0, 2, B of coordinates 1, negative 3, negative 4, and C of coordinates 1, 3. Okay, so 0, 2, 1, negative 4, 0, 2, 1, negative 4. Okay, 0, 2, 1, negative 4. Okay, this is A, this is B, and this one is, okay, C is what? The coordinates of the point C is 1, negative 4, 1, 3. 1, negative 4, 1, negative 4, 1, 3. Okay, here we have 3 points, or three vertices of a triangle. I want to transform A, B, C, okay, and the rotation about the origin through 90 degree. Okay, through 90 degree. So first of all, you should think of what? Of the matrix that transform this triangle, okay, into its image. Okay, so it will be what? We told that, look. Okay. This is 1, 1, 0. It will be 0, 1. Here, this one. 0, 1. So the first one is 0, 1. The next, it will be 0, negative. If you take this is 90 degree about the center, counterclockwise, it will be 0, negative 1. This is your matrix. Sorry. Okay. It will be, my kids, minus 1, 0. Okay? Minus 1, 0. Okay. So, now I will write what? I will write my matrix. Okay? It will be 0, 1, then minus 1, 0. Multiply by what? By the coordinates of A is what, my kids? Is 0, 2. Okay. Right. This one as it can be. Then just multiply. 0 by 0 is 0. Negative 1 by 2 is negative 2. Negative 2 plus 0 is negative 2. Then 1 multiplied by 0 is 0. Plus 0 multiplied by 2 is 0. So this one. Hence that the coordinates of A is what? Is 0, 2. And this is maps to what? Maps to 0. Maps to what? This one, yes, maps to negative 2, okay, negative 2, 0, okay. The next one, here we have 0, 1, then we have negative 1, 0. Okay, I will try to transform the point B of coordinates 1, 1, negative 4 in the rotation, okay, through the origin, or about the origin, through 90 degree counterclockwise. Okay, so this is the matrix for rotation 90 degree. Okay, so multiply by what? By 1, negative 4. Just multiply. 0 by 1 is 0. Then negative 1 multiplied by negative 4 is 4, my kids. Okay. 1 multiplied by 1 is 1. Plus 0 multiplied by negative 4 is 0. 1 plus 0 is 1. Good boy. So just right here. 1, hence B of coordinates 1, negative 4. And that's maps to B prime is 4, 1. 4, 1. Okay. The next one, we have the matrix that transform A into C prime is, yes, matrix for rotation about the origin, 90 degrees. So 0, 1, then minus 1, 0, multiply by, what are the coordinates of the point C, my kids? Is
1, 3. Okay, is 1, 3. Then just multiplication. 0 by 1 is 0. Negative 1 by 3 is negative 3. Negative 3 plus 0 is negative 3. 1 by 1 is 1. Plus 0 by 3 is 0. 1 plus 0 is 1. Hence that, or now you can write down the coordinates of the C, of the image of the point C. Hence that, this is my kids 1, 3. C of coordinates 1, 3. Okay. And that's maps to, that maps to C prime of coordinates negative 3. What? Negative 3. Negative 3. Okay. Then, in the rotation about the origin, through 90 degree, this is 90 degree, but it's white, it's with white color. 90 degree. Triangle ABC is mapped into triangle A prime, B prime, C prime, where A prime has coordinates of negative 2, what else? 0. And B prime is 4, 1. And C prime is negative 3, 1. Okay. Here we will not use geometric techniques. You will use algebraic techniques, meaning that you will work out the entries of this matrix for rotation about the origin 90 degree. After finding out, you can multiply by the coordinates of any point to find the image. Okay, good boy. The next, enable exercises. Here we have the triangle AB has a coordinates of 2, 2, 3, 4, 3, 0. Okay, 2, 2, 3, 4. Okay, 2, 2, 3, 4. This is A, this is B, and this is C. Okay, 3, 0. Okay, 2, 2, 3, 4, 3, 0. Okay, and this one, my kids, is C, 3, 0. Okay, now I will do what is it? I will try to find the coordinates of this point in the rotation about the origin through 90 degree counterclockwise or anti-clockwise. First of all, you should work out what? You should work out or figure out or write down the matrix that transform this point into their image. Okay, but the key words is what? The matrix for rotation, about the origin through 90 degree. Okay, be careful. Of course, counterclockwise or anti-clockwise is what, kids? This is 90 degree. Okay? Okay, this is 90 degree, and this is means counterclockwise or anti-clockwise. So the first we told the point of coordinates 1, 0, it will be transformed to 0, 1. Okay, good boy. This is 0, 1, my kids. Then the next will be negative 1, 0. This is my matrix that transform matrix for rotation about the origin through 90 degree that transform A to its image, B to its image, C into its image. So I will just write my matrix is 0, 0, 1, negative 1, 0. Okay, 0, 1, negative 1, 0. Then 0, 1, negative 1, 0. I multiply by this matrix for rotation about the origin through 90 degree, counterclockwise by the coordinates of A first, 2, 2. Then the same, I'll multiply by the coordinates of B. It will be 3, 4. And the last one, it will be 3, 0. Okay. Now just I will make the product to calculate or to find the product of these two matrices. 2 by 2 and 2 by 1. Okay. 0 multiplied by 2 is 0. Negative 1 multiplied by 2 is negative 2. Negative 2 plus 0 is negative 2.
1 by 2 is 2, plus 0 by 2 is 0, 2 plus 0 is 2. So hence that the coordinates of A is 2, 2, maps to A prime of coordinates negative 2, 2. Okay? Negative 2, 2. Okay. The next. 0, negative 1, 1, 0 multiplied by the Canal vector. 3, 4. So 0 multiplied by 3 is 0 plus negative 1 multiplied by 4 is negative 4. 0, negative 4 is negative 4. 1 multiplied by 3 is 3 plus 0 multiplied by 4 is 0. 3 plus 0 is 3 plus 0 is 3. So hence that B of coordinates 3, 4 and what? And that maps to B prime of coordinates negative 4, 3. Okay. The next, the coordinates of the point C. So 0 minus 1 multiplied by 3, 0. It will be 0 by 3 plus negative 1 multiplied by 0 is 0. 0 plus 0 is 0. 1 multiplied by 3 is 3 plus 0 by 0 is 0. 3 plus 0 is 3. Hence that this one it will be 3, 0, my kids. C of coordinates 3, 0 maps to what? C prime of coordinates 0, 3. Then, as a conclusion, in the rotation about the origin through 90 degree, triangle ABC is mapped into triangle A prime, B prime, C prime, or A is, we found that, my kids, is what? Is negative 2, what? 2. Good boy. And B prime is negative 4, what? Negative 4, 3. Good boy. And C prime has coordinates of 0, 3. Okay? The next.